Kia ora koutou. This is the first starter question for the COVID-19 lockdown. What I'm going to try and do is video one of these a day, and I think we're going to try it that you do this before you come onto the live stream, and then you can use the video to go through it. I'm picking questions that are also going to be good for people doing level 3 calculus, even though in some cases the topics are going to be ones you're not going to cover till later in the year. So this is a differentiation question, and it's one that uses the product rule, the chain rule, and exponentials. So there are lots of good little skills in here. It's probably a merit question if you're doing level 3 calc, but it's just a nice problem. So I want you to go to Geogebra and sketch the curve that we've got here. So you can see that it's got something times a something. So this exponential is going to have mainly that shape, but it's going to be multiplied by this thing here. So when you draw that in Geogebra, I've done a screenshot of what you get when you do your usual sort of scale, right? So it looks like this, and that kind of makes sense because we've got y equals 2 minus x times e to the negative 3x. So this part is pulling us down here very quickly, and it's being times by a linear thing, right? So when you look at that, it doesn't look like there's a minimum, but in the question I've said find the minimum. That's step 3. So when I did this, I found the minimum, and then I drew the graph, and I went, well, this is really weird. So what you have to do to see the minimum is you have to play around with your scale. I thought this was kind of cool. So if you now draw the scale, go into Geogebra and use the stretchy button to change your scale. If you make the scale tiny, even though it looks from the big graph like there's no minimum, there actually is a minimum. And the minimum we can see is down around here. So now this is just a classic calculus problem. To find the minimum, what do? Well, we take the function, we differentiate, and we figure out where the first derivative is 0. So to show that it's a minimum, I'm going to do the second derivative test on it. So let's get going on the differentiation. Just let me change the pen. So we've got y is equal to 2 minus x times e to the negative 3x. So this is a function of x, and this is a function of x. So I'm dealing with a product. I could write this as u times v. Now, if you're in my class, we've got to the point already where we're not doing it the slow way with the u and v. But for other people watching, I am going to do that. So we've got u is equal to 2 minus x. V is equal to e to the negative 3x. So du by dx is negative 1, and dv by dx is negative 3 e to the negative 3x by the chain rule. Now the product rule says I'm going to do this times this, and this times this. So dy by dx is equal to the first function, 2 minus x, times negative 3 e to the negative 3x, plus v, the second function, times the derivative of the first function. So it's going to be plus negative 1 times e to the negative 3x. Just be really careful with your negative signs. That cleans up to give me this, e to the negative 3x into 2 minus x. Oh, what have I done? Hang on. This is going to happen a lot in the next month. Right, so here I'm going to expand this out with this. We get negative 6 plus 3x minus 1. Giving me 3x minus 7 times e to the negative 3x, and that equals 0 for a minimum. And you need to explain that that's what you're doing. So, to solve, 3x minus 7 e to the negative 3x equals 0. 3x minus 7 equals 0, or e to the negative 3x equals 0. No solutions here, because that curve never touches, or that's not meant to go up at the end. That curve never touches 0, and this one here gives me a solution of x equals 7/3. Okay, so that's the x coordinate. To get the y coordinate of the minimum, I take that and I sub it in. So we get 2 minus 7/3 of e to the negative 3 times 7/3. Please, please don't use decimals. You know what I think of that. Negative 1/3 e to the negative 7, which I can write nicely like this, or at this stage I can grab my calculator and get that number out, and you're going to find that is an absolutely tiny number. Now, I haven't done that, but I'm going to look on my graph and we'll have a look at roughly where it is. So very little number, can't see it there, but here we can. Oh, isn't that brilliant? I haven't put enough of the graph in. So I'd say that this is somewhere, let's see, it's probably about negative 0.00025, right? It's a very tiny number. Okay, so how do I show that that's a minimum? Well, we're going to use the second derivative test, and for a minimum, we have to show that at the point where the gradient is 0, that the second derivative is increasing. Now, it's hard to do this without waving my arms around, but let's just look at what's happening with the gradient so that we just have a feel for how that second derivative test works. So my gradient here is extremely negative. As I head towards the minimum point, the gradient's still negative, but it's getting less negative, right? So, I have actually managed to do that quite cleanly. Wow, cool. Okay, so you can see that the second derivative test says my gradient is 0 here. That's the first derivative test, but the gradient is increasing to give me a minimum. So this is always a little bit painful. We've got dy by dx, and now we have to differentiate again. So we've got 3x minus 7 times e to the negative 3x. So off we go again. D squared y by dx squared is equal to what? Well, I'm going to do this without the UV thing because I want to get this video finished so I can have my toast before I do my first Year 9 live stream. Right, so we've got the first times the derivative of the second, which is negative 3e to the negative 3x, plus the other way around. So it's going to be plus 3 times e to the negative 3x. So collecting up all the like terms, I can take out the common factor of e to the negative 3x, and I get 21 minus 9x plus 3, which equals 24 minus 9x times e to the negative 3x. And now we have to sub in the value at x equals 7/3 d squared y by dx squared is equal to 24 minus 63/3, which is 21, e to the negative 7, which is 3e to the negative 7, which is greater than 0. Therefore, we've found a minimum at x equals 7/3. All right, thanks for watching. As usual, send me an email if you've got questions on it. Email responses will not be that fast, guys, so I'm trying to make sure I do my main lessons and a bit of extra stuff here and there, but also today just getting ready for the next 4 weeks and hanging out with my family a little bit. But if you do have questions, here's my email. Please don't all spam me. Remember, like and subscribe. Catch you later.